All right, today we're going to look at factoring quadratics. Now, let's recall what a factor is. It is a number that can be multiplied to form a product. Product, remember, is an answer to a multiplication problem. So when we're factoring a polynomial, it's the reversal of polynomial multiplication. So instead of us knowing the factors and factoring it, we're now going to reverse it. We know the answer, we have to figure out what the factors are. Okay, so we can look at problems and figure out what factors were used. So if we think back to our little t-chart, the only way we can get an x squared is if we have an x times an x. To get another x squared, that would be the x times an x. To get a negative 1 or negative x, we would have to do an x times a negative 1. That would be another negative 1 and a third negative 1. To get an x, that's an x times a 1. Okay, so I could really say that I had 2x minus 3 and x plus 1. Okay, so if I look at this next problem, I have 3 sets of problems. Okay, notice here I have the numbers outside the box only. Here I have a set of numbers outside and then some inside. Here I only have the inside. So this is what we did when we did multiplying polynomials. We took the numbers outside to figure out what the inside was. Well, now we're going to start with the numbers inside and figure out what the outside factors were. Okay, when we do this, we have this cool factor called the Xbox method, where we're given a polynomial in our standard form, and we're going to Xbox it. Okay, in order to Xbox it, you create an X. You take the A and the C and you multiply them together, and you take B. So A and C goes up here, B goes on the bottom. And then we think about what numbers create the product that we get with A and C, but would add up to the sum of B. And that's going to help us create our box. So let's do an example. So A is 2, C is negative 15. So I need to multiply those together. 2 times negative 15 would be negative 30. My B is negative 1. So I need to think about what factors are for negative 30 that would add up to negative 1. So if I think about negative 30, I could do negative 30 and 1. I could do negative 15 and 2. I could do negative 10 and 3. Nothing for 4, or I could do negative 6 and 5. So of these factors, which ones could I add up and get an answer of negative 1? Well, it would only be our negative 6 and 5. So I'm going to put those two on either side. Okay, those are going to help us fill in our box. So in our box, our first term is going to go in the top left box. Our third term is going to go in our bottom right box. And then I'm going to use these two factors to fill in the middle. So this is going to be negative 6x, and this is going to be 5x. Okay, so now I need to think about, okay, what can I multiply together? So in order to get 2x squared, that has to be a 2x and an x. If I look this way and I make it 2x, that could go into both of these, 2x and 2x. But if I look this way, the only common factor they have is x. Then I need to think about, okay, how do I go from x times what would give me 5x? Well, that would have to be a positive 5. If I have 2x times what would give me negative 6x? that would have to be a negative 3. And then I would check it, and I would say negative 3 times 5 would give me negative 15. So the factors for this quadratic, for this polynomial, would be 2x plus 5 times x minus 3. Okay, let's try that some more. So let's go to the next one. All right, so we're given x squared plus 4x minus 12. Again, we're going to do the x box. Our box is always going to be a 2 by 2. It's never going to be anything else. So let's multiply. A times c, so that would be negative 12. B is our bottom. So thinking about negative 12. So again, think about your factors. Negative 12 and 1, negative 6 and 2, negative 4 and 3. Okay. What numbers can I multiply together to get negative 12, but add to get 4? Well, if I do this set, that would give me negative 4. But what if I were to make this a positive and make that a negative? Would that give me added up to get a negative 4, but still multiplied to get that negative 12? Yes. So those are my two numbers. So now I know this has to be negative 2x. This has to be 6x. I take my first term, put it in the top box, my last term, and put it in the bottom. All right, so now let's think across. If I were to think about this, the only thing that has in common is an x. Here, the only thing that has in common is a 6. If I go down, the only thing that they have in common is an x. This way, they have a negative 2. So my factors would be x minus 2 and x plus 6. All right, let's do number 2. 2 times negative 40 would be a negative 80, negative 11 at the bottom. All right, so let's think about negative 80. You've got negative 80 times 1. You've got negative 40 times 2. There's nothing that can go into 3. You can do 4, negative 20. You could do 5, which would be negative 16. Can't do a 6, can't do a 7. You could do an 8. And that's it. So, which one of your factors could you multiply to get negative 40 or negative 80? That's all of them. But we want to add to get negative 11. That would be this set right here. So negative 16 and 5. So I have 2x squared. I have negative 40. I have 5x and negative 16x. If I look at this row, I could do an x. To do this row, that would be a 2x. This would have to be a 5. Down here would have to be, because that's a 2x, this would have to be a negative 8. Because negative 8 times 5 would give me that negative 40. So my factors would be 2x plus 5 and x minus 8. Could I reverse these and say x minus 8 and 2x plus 5? Yes. It's all about how you look at your box and where you write your numbers. If I had put 5x and negative 16 in opposite spaces, these factors would have been on the opposite sides. All right, let's do our next one. Excuse me. All right, let's multiply. 4 times negative 3 is negative 12. B is 4. So you can go back up here to your negative 12. Again, you want a positive 4, which is going to be your 6 and negative 2. So we have 4x squared here. We have negative 3 here. We're going to have negative 2, and we're going to have 6x. So if I look at this row, the only number that they have in common would be a 2x. For this way would also be a 2x. 2x times 2x is 4x. This is 2x times what would give you a negative 2x? Well, that's got to be a negative 1. 2x times what would give you a 6x? That would have to be a 3. And 3 times negative 1 would give you your negative 3. So your factors are 2x minus 1 and 2x plus 3. All right, number 4, this should be a squared, not a big 2. So let's Xbox it. 6 times negative 6 is negative 36. 5 goes on the bottom. All right, so let's think about negative 36. That's negative 36 and 1. That's negative 18 and 2. Negative 12 and 3. Negative 9 and 4. And negative 6 and 6. We want to get positive 5. Well, if I do this row, I get a negative 5, which means this needs to be a positive, this needs to be a negative. So it'll be a 9 and a negative 4. So I say 6n squared and negative 6. I say negative 4n and I say 9n. All right, so to get 6n squared, that's a 3 and a 2. So if I look across here, these would both be a 2n. If I look down this column, this would be a 3n. So 2n times what would give me a negative 4n? Well, that's a negative 2. 3n times 3 would give me 9. Negative 2 times 3 would give me a negative 6. So factors are 3n minus 2 and 2n plus 3. All right, look at number 5. There's a problem. It's not in standard form. So I need to do the inverse operation to get this to the other side. So I would say that is a squared minus 24a plus 144 equals 0. So when I Xbox it, I want to get 144 and I want to get negative 24. All right, I know 144 is 12 times 12, but I want negative 24. If I did negative 12 and negative 12, that would give me a negative times a negative is a positive, but when I add these, they would get me negative 24. So I have a squared and 144, negative 12a, and negative 12a. So to get an a squared would be an a and an a. To get negative 12 would be a negative 12. To get negative 12 here would be a negative 12. So these factors are the same, which means I could write it as a minus 12 squared as my factors. I could write it out, but there's no need to because it is the same. All right, let's do number 6. Again, this is not in standard form, so we got to do the opposite or the inverse operation for that 9. So this would be 16x squared minus 9 equals 0. So when I Xbox this, I have no b term. So b has to be 0. 16 times negative 9 is a negative 144. Same thing as this, but I want 0. But if I add 12 and 12, if I do a negative 12 and a positive 12, that gives me 0. So now let's work it out. So this needs to be a 16x squared. This needs to be a negative 9. This needs to be a 12x. This needs to be a negative 12x. Again, look at your factors. I have a 16 and a 12. The only thing I can pull out is a 4x. Another 16 and 12 would be a 4x. But now I want to think 4x times what would give me 12x? Well, that would be 3. 4x times what would give me a negative 12x? That would be a negative 3. And 3 times negative 3 is negative 9. So my factors for this one would be 4x plus 3 and 4x minus 3. All right, so let's answer some questions. Why is the factor form useful? Hint, quadratic solutions. Well, quadratic solutions were what are quadratic equations when graphed. That was your x-intercepts. If I were to graph these x-intercepts, these solutions that I factored would help me. They're actually telling me what my x-intercepts would be in these factored forms. Okay, so the factored forms can be used to determine the solutions or x-intercepts for the equation when set equal to 0. So if I were to set a minus 12 equal to 0, I would get a equals 12. And if I were to graph this equation, I would get one solution of 12, 0 as my x-intercept. Okay, so let's practice that. So here's my equation. I'm going to factor it. N times negative 12 would be negative 12, and I need it to equal 4. So if you think back to your 12, that would be a 6 and a negative 2. So n squared and negative 2, 6n, negative 2n. So that would be an n and an n. This would have to be a negative 2. This would have to be a 6. So I have n minus 2 and n plus 6. If I were to set this equal to 0, n minus 2 equals 0, and I would go to solve it, I would get n equals 2. And I would solve this one. I would get n equals negative 6. So let's graph these. So if I pull out my handy-dandy Desmos calculator, and I were to clear out all of my stuff, and I were to put x squared, I'm not going to do n, but x is the same, plus 4n minus 12. Oh, I did n's instead of x's. Whoops, let's fix that. X, there we go. I have an x-intercept of negative 6 and an x-intercept of 2, which is exactly what I mathematically factored it out to be. Okay? Does this mean we can only graph and we can't show factoring? No, because there are going to be times where we need to factor. But it's a good way to check our work. So, let's do our last one. Again, we're going to Xbox it, just like always. 5 times 3 is 15, and 8. So let's think about 15. That's 15 and 1, and 5 and 3. Well, 5 and 3 added together is going to give me 8. So 5x squared and 3, and I'm going to say 5x and 3x. All right, so if I look here, the only thing I can pull out is a 5 and an x. If I look here, the only thing I can pull out is an x, because 5x times x would give me 5x squared. 5x times what would give me 5x? 1. X times 3 would give me 3x, and 3 times 1 would give me 3. So my factors are x plus 1 and 5x plus 3. Now this is where it gets funky, because if you noticed over here, x minus 2 gave me a positive 2. N plus 6 gave me a negative 6. So if I have a positive 1, I know one of my roots is going to be negative 1. But what about this one? What happens when I have a problem like this? Well, if I were to work this out, and I'm going to get a different color so we can see this. If I were to do 5x plus 3 equals 0, and I were to solve my two-step equation, like always, I notice that I get a fraction. I get negative 3/5. So this is saying that I should have an x-intercept of negative 3/5. So those should be my two x-intercepts. So let's check this on our handy dandy Desmos. Let me move this over here so we can see. And we're going to say 5x squared plus 8x plus 3. All right, let's zoom in so we can see this because those are kind of little. Oh, I noticed they're less than 1. All right, what do we notice? That we have -1 and -0.6. Is -3/5 the same as -0.6? Well, if you're not sure and you check using Desmos, yes, it is the same. So that shows us right there that what we got when we solved that algebraically and what we graphed are the same. And that is factoring.